Welcome to a new video of lead code question series. In this video, we are gonna solve a tree question. Actually, in my opinion, that it's a bit more difficult in compared to the previous question. And the first, let's see what is the question, and we have to find out first the question, and after that we will see the solution. Okay, the first, if you look at the example, we are gonna we are given a tree structure that you can see its definition class in here. It has a value and left, that's left and right, are also maybe are also a tree node structure. So the question asks us the return preorder traversal of the nodes values. And if you look at the question, the example, for example, in this case, we have to return 1, 2, and 3. Why? The request of this question asks us a typical kind of traversal that it named it preorder. Let me show you a complex example to find out it better. I drawed it before. For example, examine that you have this tree. 1, and it has a left node. 2, it has a left node. 3 and 4, 6, 7, and 5. How we should traverse this tree? It asks us in this kind of traversal, we have to first save root, then left, and at the end right. Okay, keep in mind this, and let me to insert sorry, another, yeah, another text to write the return object. Okay, so in this example we see at the first one and save it for the first node values. Then we go to the 2 and we write it as the second. Then we go to the left also until the leftmost. We continue this approach until the leftmost of the nodes. Okay, and 3 is the left node of the this side, so we have to return to 2 and look at the next node, that is 4. 4 has a left side, that is 6, and return back to this 4, and then look at the right side of the 4, that is 7, and there aren't any other nodes in this side. We have returned to 4, then we have returned to 2, we have returned to 1, and then return the 5. So it's a preorder traversal, and in this question we need this structure, we need this return structure for our answer. So this is the question, and what is the solution? For solving this solution, we get help from a stack structure. In a stack structure, we keep our traversal way and keep the nodes on a stack, and then we return to a stack in future and check the nodes. But first, we insert the right side. The first, if we get a node that is root, so we save it, save root, then insert the right side into the stack, and then insert the left side. Why we insert the right side at the first and the left side after that? Because if you know the structure of a stack, in a stack, when we pop an element, it's return for us the top element of the stack. Okay, so because because of the procedure that we want left for the first and before the right element, we have to insert left elements after the right, because we are gonna access to left elements sooner. And yeah, we continue this approach until the end of the stack. So for implementation of this approach, I defined a final, that is our return structure, and I define a current that shows us the current position that we are in tree, and also I define a stack that I defined it as a empty array. So I check first that if our tree is null, so we have nothing to return, so we return an empty array for this kind of examples, because the root is empty and we have to return an empty array. And otherwise we have continue until because we are working with a stack, so we check the stack. We continue until the stack is not empty. Okay, but before that we have to initialize the stack. So the first I use from array push function stack and root, and in final we use it's not important, but we import current or root value, because at the first we have to insert the root value. Okay, so at first we update our current and pop the top element of a stack. Okay, and then we update our final. Okay, and we check that if current has right, as I told you, because we first check the right side and array push the stack and current right, sorry, and then we check for left side, array push the stack and left. Okay, we continue this approach, this loop until the end of the stack, and we don't have anything in the stack, so at the end we return $final. So let me to test it. Okay, we have a repetitive element. I think it's in this line. Let me to test it. Yes, because at the first, because we insert a root inside the stack, into the stack, and at this line we pop it, we get it the root element, and at the first time it's equal to the whole root. So in this line we get the first element, that is 1. I don't need insert it again. It's my solution, and I think we can there are many other solutions for this question. You can solve it by yourself, but it's one of the existing solutions that you can use it. I hope you enjoy from this video, and I will see you on the next episode.